Hello, discrete math fans. So remember, we talked about the expression n choose k, and this is the number of ways of selecting from a class of n students a committee of k. So k is less than or equal to n. We came up with a formula for computing this expression, and that's this right here. N choose k is equal to n factorial over k factorial n minus k factorial. These numbers are called binomial coefficients, and we'll talk about why later in this section. Now there's a very nice way of displaying values of n choose k for various values of n and k. So what we're about to look at is called Pascal's triangle. All right, this is Pascal's triangle. And for convenience, I have labeled or marked the rows on the left side, and then this whole thing is the triangle. So you'll notice, like, here's row 2. Row 2 has 3 entries, 1, 2, 1. Row 3 has 4 entries. Row 4 has 5 entries, and so on. So this is Pascal's triangle. This is very useful, and we're going to make reference to it. Might be a good idea for you to have it to be able to refer to later on. The kth entry, starting with k equals 0, in row n is n choose k. So we're always going to start counting at 0. That's the way a computer scientist would start counting. For example, if you refer to your triangle, 6 choose 4 is 15, 8 choose 8 is 1, 7 choose 1 is 7. Again, keep in mind that we're counting in each row starting at k equals 0. So when we say 6 choose 4 is 15, and we say the fourth entry in that row, we're starting counting with k equals 0. We also start counting the rows with n equals 0. So the very top row that only has one entry in it, that's row 0. Let's talk a little bit about how Pascal's triangle is constructed. The outside of the triangle, that's all ones. The inside numbers are created by adding the two numbers that are above them. And by above, we really mean above to the left and above to the right. So take a look in row 7. There's an entry that's a 21, and that comes from adding the 6 and the 15 above. And again, we mean above left and above right. Now, we showed 10 rows of Pascal's triangle, but really, Pascal's triangle goes on forever. It's named after the French mathematician Blaise Pascal. He lived in the 17th century. But in fact, the idea of Pascal's triangle has been known for many centuries. Pascal's triangle is a really important object in enumerative combinatorics and is one of the most studied mathematical objects. There are endless interesting properties of Pascal's triangle. We're only just going to be studying a few of them. Okay, that's all for now.